So I'll want to use a similar Venn diagram that I just used before. There's a couple, and we have this every time we have a conversation with our clients to really understand maybe what's the best starting point. What should you be concerned and focused on first and foremost, and what are maybe more, in that case, second order lens specs that can already be discussed and adjusted later. So first order lens specs, this is really something that is inherent and defined by the optical stack. That is quite often for an off-the-shelf and lens kind of locked in stone for us to a certain extent. So these are things like the effective focal length or the back focal length, the distance between the mechanical back end of the lens and actually your sensor plane, the image circle, the f number to a certain extent, the distortion profile, the overall length of the lens, the obviously MTF performance, CIA, all those things are defined when we build and design a lens for the first time. These are all nominal features of the lens, first order lens specs that can't necessarily be changed. But then there's a whole list of second order specs, the filter, particular coatings, some mechanical features like the barrel. You maybe see a barrel with an M12 thread and you wonder whether this could be M10 or M14, or maybe you want to have a particular feature on the barrel to maybe align it with your internal processes. Can a lens become a module, right? Can you mount the sensor to it? F number can be changed to a certain extent. So this is where we define between first order lens specs and second order lens specs. And then the last part is obviously you want to align and adapt the particular lens also to requirements in your particular industry. The first order lens specs, this is actually what we're going to address here today, because this is where our online tools are going to help you navigate and get to a set of lenses that might be a good choice for your application. The second order lens specs is actually what we're going to address in 2 weeks from now in the next seminar, when we discuss what actually can be customized and how would that look like for a particular lens. So ideally, right, everything comes together. You have a particular requirement for your application. You find a lens that is completely checking out everything on the first order lens spec side and also on the second order. But quite often it doesn't happen, but it doesn't really matter, because if you already find a match between the first order lens specs and your requirements, it's a very, very good starting point to do a proof of concept and do a testing. Again, adjusting the barrel to fit your needs, maybe changing the thread size. This is all minor stuff that can be done later. So the focus should really be on the first order lens specs initially, because this is a very, very good starting point. If that's a match, you're almost 90% there. So let me show you a little bit how we address this. So again, the first step is you use our online wizards, and I'll go through them and maybe explain a little bit what wizard and what tool is going to use to what purpose. But again, high level, you have the sensor part number maybe already defined, or you at least know a sensor class or resolution, and you have an idea of at least any one of those field of view, focal lengths, TTL, some of those requirements. Everything else is more second order. And what I wanted to point out as well, so these are the tools that we at Sunex actually use internally. So whether I'm in a customer conversation or Ben will get asked some of those questions either live or by email, we go and use the same tools, and Sunex is making this exact same tools available to you. And the benefit is really, we're not just having 1 or 2 lenses, we have a lot. And those tools really help you to navigate through those lenses, maybe make a pre-selection before you get in contact with us, or simply you just ask us for some support. We're using those tools. When I reply to those initial requests, I'm quite often explaining also what type of tools are used online to actually get to this point. So let's get started with this. So,
hey, Ingo.
Yes.
I'm just going to jump in here real quick. We got an interesting question. The question is, what is the number of elements in each lens, and what are the pros and cons of having more or presumably less elements? I thought this was an interesting question. The number of elements in our lenses, we do make what we call fixed focus multi-element lens assemblies, and the elements can range from 3 or 4 all the way up to 10 or 12. And really the answer is there's no pro or con necessarily to having more elements. We use as many elements as it takes to meet a particular technical need. When we talk about elegant design solutions, the idea is not to use more glass or plastic than is actually needed to meet the technical demand. So that simplicity of design pays dividends in terms of the cost of the lens, but also in the efficiency, because the more surfaces you have, the less light you lose and so forth. So Sunex is very good at making what we call elegant designs using as few elements as possible. So a typical lens, though, might have 6 to 8 elements, and then we'll add more as necessary for particular applications or to fit a particular requirement. So I thought that was an interesting question.
Maybe if I'm adding to that, I had once a customer also that asked me, so how can I now compare, right, 2 different suppliers that I maybe consider? And on paper, quite often designs become similar at one point, because obviously you as the client, you're going to use and send the same requirements maybe to 2 or 3 different suppliers. So ideally, all of those suppliers eventually, if physics allows, will come up with something similar, right? In terms of MTF performance, you maybe gave a size requirements at a maximum dimension. So everybody ideally finds a solution, but the solution will always be different if you look a little bit deeper into it. And one thing that is nice to compare, for instance, we see that sometimes that we often use 1 or maybe even sometimes 2 elements less for the same performance than another supplier. And this is simply something that can later then often reflected be in a lower piece price when we talk about mass production. It's simply also reducing complexity. It's always great in manufacturing if you can reduce complexity, and it just makes the process more controllable. So this elegant design quite often really, if you do an apples by apples comparison, it is quite often seen in a reduced number of elements, or maybe the elements are more simple in their individual structure. And yep. This reflects simply in the design experience that a particular company has in those fields. So great question. Thanks for bringing that up.
Yep. Yep. Thank you.
So the online visits, again, same tools that we use internally, all the Sunex employees. If you go to sunex.com and you scroll down a little bit, we have a dedicated section there. Under quick find, you can actually type in right away imager specifications like the X and Y resolution and the pixel pitch, and you immediately get a list of our off-the-shelf lenses and the resulting field of use there. Sometimes also you get a referral, you hear it from a colleague or maybe from someone at Sunex say, hey, lens XYZ is a good lens. So you can directly type in the part number here and you get directly to that lens under the data sheet. In general, if you want to have more overview approach, there's an icon you can click for the Optical visits. Again, these are free tools. We just ask you to register one, so with your email address, so we can also provide support. And from then on, all the tools are available to you at no cost. And there's a couple of tools. I'm just putting like 4 or 5 of the ones that I personally use most in here. And they all kind of, in the end, bring you hopefully to the same point. It's just a little bit different starting points depending on what information you can share. Sometimes some of the information can't maybe be shared for confidential information, or maybe simply the project is not that far advanced that some of those requirements are still more open. So the visits quite often differentiate in what is your starting point. So before I show those live, let me quickly just talk you through it. So we have one that I pretty much use all the time is either finding lens by imager specification. Again, this would be XY resolution and maybe the pixel pitch. Or if you really want to select a very specific imager sensor, we have a database that you can search by imager class or by manufacturer name or by particular part number. And I'll show that in a second. We then have another set of tools where you maybe a little bit less depending on a particular sensor part number, but you have a particular requirement in regards to field of view or effective focal lengths. You could even select here from a drop-down list existing Sunex part numbers and say, okay, if I would use this lens on this particular resolution, what would be the resulting field of view? So very, very powerful tool. Once you pick the lens or two, I'm quite often using the depth of field calculator, not as a starting point, but rather as another add-on tool. If I have maybe a finite imaging application, I have a specific sensor and setup, I can then actually check what's the depth of field for this particular setup. So that helps me in maybe defining and fine-tuning my overall setup to see what's the tolerance of maybe movement I can allow in my hardware setup, so to make sure that the lens and the object is always in focus. Imaging optic solver, this is almost more like geometry. It's a very early starting point. You maybe just say, you understand how big the object is that you want to image. You maybe have an idea how far that object is away from your camera setup or from the sensor, and you also have a rough idea maybe of what's the sensor geometry, and this will help you create a starting point. And then the last one is just another collection of advanced search and filter tools to, again, navigate this large amount of lenses that we actually make available to you and have available in stock. So in summary, this is a little bit kind of, again, depending what is your starting point. You can use the different online wizards. And if I again take here the first column, if you go by image specifications, resolutions, or part number, you get the entire online portfolio that we have listed by resulting field of views. And again, that includes the specific distortion profile of the lens. And then depending, the other wizards help you to kind of narrow down the selection already a little bit. So again, different starting points, slightly different results, all intended to give you an idea which lens would be the best fit. And quite often, again, very, very good starting point for a conversation with myself or with Ben or our colleagues. What comes out now, the result that we present to you is always like similar to this one. You see a particular part number, like here, the DSL 189. In this case, we have 3 different versions on it online, which are the different filter configurations. And this gives you a list. And if you see there at the bottom, roughly here in that area, down here, sometimes you have a more limited list depending on how tight you made your requirements, but sometimes you really have a list of 1, 2, 3, 4, 5 pages of options, and you can scroll through this one as well. One thing is also that's quite often missed, but it's a very important point. You see here, for instance, the DFOV, so the diagonal field of view, 186, and there's this little plus sign, the little marker to it. And there's a little note here at the bottom, because in the end, depending of the field of view and depending the nominal design of the lens, what this is actually speaking to is how the image circle of a particular lens is matching geometry and dimensions of your sensor. And the plus sign indicates that the image dimensions that can be in horizontal, vertical, or diagonal exceed the image circle size of the lens. So here in this, yes.
Jumping in again here, we got a question on exactly this topic, and the question is lens shading or vignetting a function of the lens or the sensor? And this goes along with what you're saying here. And I think if you interpret the intent of the question, it actually be both. Lenses do have a phenomenon or feature called vignetting, but when you're matching a lens to a sensor, what you're actually seeing, if the image circle isn't large enough, is clipping of the image circle. So if the image circle doesn't cover the whole sensor, then you're going to get this kind of circle effect or dark corners. And even if you do cover the sensor, you still have this function of lenses that we call relative illumination. And all 3 of these things kind of play together to give you a center to edge shading effect on the sensor. Now, a lot of sensors have compensation for this type of thing, but you do want to make sure, generally speaking, except in the case of where you're trying to have like a fisheye 180 or 360 degree configuration, you do want to make sure that the image circle in most cases covers the sensor. And the interesting thing is what you're talking about now is our wizard does that automatically. When you put in a sensor part number or specification, it will only show, except in the case of fisheyes, and that's the key thing here, it will show lenses only which cover the sensor. Now, as you're saying, if there's a plus sign, like in the example you're showing now, that may indicate that the image circle is smaller than the sensor. And again, in the case of fisheyes, that may be by design.
Yeah. And again, there's no real right or wrong. In the end, it has to fit to your particular application, right? We have sometimes application where the customer is totally okay if there's a little bit dark corners. Other requires to have the lens completely fill the sensor. Others are okay if the field of view is matching the horizontal dimension because they plan to crop it anyways. So we just try to bring up tools that make those things obvious. There's a great knowledge center article on Sunex.com that actually is showing the relation of image circle to sensor size and what we mean by when it's overfilled or underfilled. So that's maybe a good article to reference here as well. So Ben, again, thanks for bringing that question in here. What I also want to show you, there's actually a lot of information that you get for a particular lens. And if you simply click on the lens part number, you get the data sheet. You see in this data sheet, there's a table included. And again, the table is actually speaking to the first order parameters, right? What is really key to this lens? And then you also have typically a second or third page with the mechanical drawing. Depending if we recommend a holder to a particular lens, you have access directly to our list of holders. Quite often we recommend to use Sunex holders with Sunex lenses because it's just simply a precision mount where the thread size and tolerances are perfectly matched. So again, you want to make sure you have a good aligned imaging system, and a good match between lens and holder is the first step to that. I mentioned before, you have the overview of the resulting horizontal, vertical, and diagonal field of view. We just discussed the little plus sign there, so be aware of that. You have access to, depending on which wizard you used earlier, to calculate the depth of field or potentially calculate the field of view. And then one of the most important things, obviously, I would assume you go to use those wizards and go through our online tools because you look for a particular sample to actually test. So we also have the availability here. You can check the stock status that we have in the United States. You can basically then order directly, set up your own profile, use a credit card, and a particular sample should be with you in just a matter of days. If you maybe like to discuss with us a larger volume, obviously we have our standard contact sheets, but you can also directly from here trigger a request for a volume quote, which, to be honest, we would never just simply reply, that's the quote. We would always make sure we make an effort to actually initiate a conversation with you to really understand what you're trying to achieve, and maybe also recommend another 1 or 2 lenses that would be a good fit, because we want to make sure you get the perfect solution for your application. So moving forward, I give it one more try with a polling because I would like to understand, because that's in the end today's context, who has actually used our wizards already and to what extent. So I try to do another poll. Let's see if this is actually coming through or not. Again, I noticed before you were chatting to Ben and myself that those did show or didn't show up, but it looks like I'm already getting results in here now. We're already having 8%. So apologize for the second poll. This one seems to be better suited. The results are coming in very quickly. We already have over 50% now. And it looks like some people are familiar, but it's good. There's also a large portion who hasn't used them before. So I hope this webinar is actually very useful for you in that case. And again, myself, I always tend to use 1 or 2 of our online wizards. And sometimes I'm made aware of, oh, there's another one that would actually help me very much in selecting the right lens. Okay, so, yeah. There's
one interesting question here, Ingo, that somebody brought up. And the question is, as far as distortion goes and wide angle and fisheye lenses, the question is about de-warping and software. And it's important to note that because Sunex is the designer and manufacturer of all of these lenses, we do have distortion lookup tables which would allow you to implement in software and correct or de-warp to a very exacting degree the distortion in the lenses. So if you're doing an OEM project and you are trying to remove the distortion, that's something that you can contact us about, and we can help you with that for any lens in our portfolio.
Yeah, perfect. We had at the beginning of the webinar, if you watch the recording, or then also at the end here, Ben's and my email address is listed there, and also our general contact, which you also find at sunex.com. Those are definite topics. Please reach out to us. We'll definitely initiate a conversation and make sure we give you the data that you need to be successful in your projects. So I want to use now just 2 examples and actually go online and show you the wizards live. First example, and again, I want to make sure this is just kind of a little bit more generic example. This is for the automotive industry. We do a lot of different applications in our automotive, right? Whether this is parking, which kind of includes the rear view, surround view, driving, infotainment, lighting, a lot of different things. And quite often we get emails which don't tell the whole story. And I can understand that because obviously a lot of things are confidential. But you might wonder sometimes, so why are they asking me all these questions, right? We typically ask a couple of basic questions because they help us to recommend the right product. And typically the first question is that we have, so did you already pick a sensor by part number, at least by sensor size? And for instance, in automotive, this already helps us to reduce the number of possible applications from our experience, which again helps us to think about your application and questions we should ask. And maybe we suddenly think about temperature profiles. Right, we always think about not only is this the right lens for your requirements, for your spec sheet, but we want to make sure the lens can actually excel in your application. So this is why sometimes we maybe ask one or two questions and you wonder why. Right, next thing is what's the application, right? If you tell me for automotive that you look for a horizontal field of view over 190 degrees, I probably know it's not a forward vision application or like an e-mirror application, right? We're probably down to it's a rear view, a surround view, or maybe an occupant monitoring system. But then other parameters again, and if you think about one of my first slides about first order parameters, right? What is your F number? What is maybe the maximum physical dimensions you can live with? And filter, I'm typically asking as well, and this is less first order parameter, but this is already, it makes me thinking of, okay, do I have actually a lens in stock that I could send over to you in the coming days, right? So this is typically a couple of parameters. And with that information, depending if I have the sensor dimension, part number, or just the resolution, I'm always calculating out the physical dimensions. Again, the width, so the horizontal or the height, the vertical sensor resolution, and the dimension in the diagonal. Is important to see if the lens is actually matching from an image circle perspective, because you also want to have a lens that is kind of nicely matching the sensor and not overfilling or underfilling it. And then I do what I can recommend to you now, really just go online and use one of those wizards. And I will switch here to my web browser. And I'll just show you this live. So you're on sunex.com now. And as I mentioned before, if you scroll down a little bit, you have what I showed before in the screenshot. And again, maybe staying with the screenshot I showed before, someone tells you, hey, check out the DSL 189. That's a really great surround view lens, very great performance in the visible and even the IR range. You type in the part number and you get exactly to this, what I showed you before. And from here, again, you can navigate to the data sheet. You can see what's the stock availability. In this case, you see we have 3 different versions of it with a 650 IR cut, with an IRC 41, which is a dual bandpass filter for visible in the IR. And we also have a version that doesn't have an IR cut built in. So again, very quickly from our main page, you can navigate here. If you now want to use the wizard, maybe let's see if we get to the similar result. You just click here on this tile for all the wizards. And again, you see the wizards that I mentioned already before. If you click on them for the first time, you will be asked to quickly register. If we go to our imager database, again, here you have a particular sensor maybe in mind. And again, Sunex is rather sensor agnostic. We work with all the different sensors, obviously depending on the application or even maybe the time, certain sensors are just dominant in one particular application. And we try to add them to our database so that you don't have to think about in resolution. You can just think about in terms that you think, and maybe just simply pick the right sensor that you're looking for, right? If it's in a database, you see the sensor listed. If you click on the sensor part number, you see the sensor specs. If you click on find compatible lenses, you get the entire list of lenses in their field of view matched to the sensor. What I want to do now is I want to go this path that is very typical, where someone is sending me an email just with some first level specs for the sensor and said, okay, do you have anything in this range that maybe gives me 190 degrees or more? You just type in those data, and then you see exactly what I got before, a long list of lenses and their resulting field of view. And you can always, what I always do, I kind of check a little bit on the lens summary. keeping an eye on, is this, for instance, from a resolution perspective, something from a size, image circle, sensor class, something that I'm looking for. And as I mentioned before, in this case, we have 12 pages here. And at one point, if I check here my sensor, the resulting field of view for the sensor, I at one point say, okay, I was looking for 190 at least, and here we are, we're back at the 189. I see it's 193 degrees on this particular sensor. Vertical is thus 160, and we already saw before diagonal 210 with that plus, so it means it maxes out at the maximum field of view. That's the nominal design spec for this particular lens. And then we know in that case it will have slightly dark corners on this particular sensor. So if I go from here now and open up the data sheet, again, I have the high level specs, I get the CRA information, can check if this is matching with my sensor, and then I get the fundamental technical drawing. I can also go from here, what I mentioned before, for instance, see are any of those samples in stock. This particular version with the dual bandpass filter, the IRC41, I see currently in the United States, we have 136 pieces in stock. I can just add those to my cart and then simply order them online. So it's a very quick and easy way to navigate based on a very specific sensor, see a resulting field of views, again, based on the distortion profile, and I can narrow down the results quickly and navigate through the long list of possible lenses to the one that actually suits my needs. And we have a lot of customers who work with us for years. They don't even call us anymore. They just go through here, pick the 2 or 3 lenses they want to test samples, order 2 or 3, and again, in a matter of days, they have those lenses in their laboratories. Other customers, they maybe want to have another confirmation, so they go through those visits, say, hey, I found the DSL 189 and maybe the DSL 182. Which of the 2 do you think is suited better for my application? And then again, we typically try to have a little bit more in-depth discussion of what is maybe the concern or what are maybe the particular applications. So again, just a quick example for the automotive industry, how to use our visits there to get some samples. The second, and also in that case, last example, because I want to be respectful of your time, is maybe something where the initial information is less defined. Maybe the application and the team already decided on the sensor class, maybe 1/2.5 sensor. We know what we want to look at. Yes, we want to maybe here in a more biometric imaging application, look at something that is maybe 20 millimeter big. It's a small setup, maybe more something like a kind of a microscope or maybe a dedicated device in a box. There's not too much space, so the object distance is maybe small, and yeah, we want to have a certain resolution because we want to see certain features on the image, right? So how do you go about to find a starting point for this one? Again, for myself, I typically calculate the sensor dimensions for me. This is simply based on the 1/2.5 imager class, and then I go online. In that case, since I don't have a specific resolution yet or a part number, I would probably use the imaging optics solver. Also, that I want to show you as another example live how that would actually look like in this case. So we're going back online. I'll just go back here to Sunex. And what you see in this case now is I'm using, again, our optics wizards. And in that case, I'm using the imaging optics solver. So in this case, my application, right, I said it's maybe a microscope. So this is a finite distance, finite imaging application. So I'm selecting here the second option. And I'm now putting in just simply a couple of information that this graphic is asking me for. We know what we want to image is about 20 millimeters based on the imager class. Again, that was a 1.25 imager. We know that it's mapping to a horizontal dimension of 5.7 millimeter. And in that case, my object is from my camera about, I think I said 35 millimeters away. If you calculate this now, I simply get a result of a lens with a focal length of 7.76 millimeters would be the right thing. If I search now for this type of lenses, you see it broadens up the filter a little bit. So it starts from 7, maybe goes to a focal length of 8 or 8+. And again, I can go through the list here and see now from the default parameters, which one is a good lens. For instance, here the 944. If we want to look at this one, it's a good lens for machine vision. I see the fundamental specs. I see the dimensions. I can see if this lens would actually fit into my application from an optical but also mechanical perspective. And what I mentioned before, I can maybe go from here, say, okay, if I would use this lens now, how stringent does my mechanical setup has to be? So if I go into this depth of field calculator from here, I can put in the blur size, and blur size is now a function of the pixel size. Again, the sensor is not selected yet, right? We have an early starting point, but let's assume we pick a sensor, maybe somewhere 3.5, maybe 4 micron pixel size. Again, this depends a little bit on your final selection. And then you maybe allow like 8 or maybe 16 micron as a blur size. It's a function of the pixel size. We know the object distance is 35 millimeter. That has been defined already in our application setup. And I can calculate now the nominal object distance, but I can also calculate now what is the band around this nominal object distance. And basically you can see that if your object is somewhere between 34.3 millimeters and 35.8 millimeters in front of the camera, your image should be in focus. So this is just another example how all those tools can actually work together to help you, again, find the first set of lenses that might be a good choice, and again, potentially drive a discussion. So again, where do you go from here, right? So my recommendation is always, because I think it informs the discussion, try it out, go online, narrow it down, and then get in contact with myself, with Ben, with all of our other colleagues, right? Whether that is calling in by email or through some of the online forms that we make available, and just say, this is my rough application. I found this and this 2 lenses. Can you A, confirm that they're a good choice? And B, could you recommend any others? And then again, typically we have a conversation. This goes back and forth a little. We maybe exchange some data sheets. And then very quickly we get to this point, say, hey, I have that particular lens, the 189 in stock. I currently have quantities for the 650 IR cutoff and the dual bandpass filter. And then we can go ahead and either via a quote or directly via an online order, you can test, order a couple of samples, and your test can be underway in again, just a matter of days. So this is kind of what Ben and I wanted to present today. And again, it was less technical, but very, very fundamental, because if we move forward into more technical discussions, we want to enable you to be able then to navigate our portfolio and actually find the right lenses around a particular technical topic. So we really believe this is going to help everybody moving forward to be able to pick the right lenses for your projects. I want to stop here, Ben. Do you have a couple of other questions in our Q&A pod?
Yeah, we'll open it up to any questions. Nothing outstanding right at the moment, but let's give it a minute. Somebody did bring up an interesting question that has kind of an involved answer potentially. So maybe we can talk for a minute about CRA while people formulate other questions. Well, CRA is the Chiefrey angle, and everybody may be familiar with this because every sensor has a CRA spec. And the lenses that we sell in the spec data sheet online also have a CRA spec. And the question was, how does the CRA influence lens selection? And without going too deep into the technical side of things, it's sometimes difficult to say what the CRA impact of a particular lens and sensor combo will be. Suffice it to say that if you can minimize the CRA mismatch, there's less of a chance for issues. That doesn't mean that if there's a big mismatch, there will necessarily be issues. And so we always recommend people test the lens on the that they're actually using, which to your point is kind of the final step. Once we identify a lens, if there's any concern whatsoever, including the CRA, that's something that we would test. Online on our resources page, there is a white paper about CRA mismatch that I recommend that you read if you're interested in CRA effects. But in every use case and with every sensor and with every lens, the result is a little bit different. Some lenses and sensors have extremely tolerant CRAs. and it will work, you know, even if there's tens of degrees of mismatch. Other sensors and applications and lenses are more critical of CRA mismatch. So unfortunately, not a super straightforward answer, but hopefully that helps provide some guidance. There's another question here regarding CRA. How is CRA different from field of view? The field of view is independent, at least to the first order, from CRA. The CRA technically is the angle at which individual rays, oversimplifying this a little bit by way of explanation, but the CRA really defines the angle at which the individual rays enter the pixels on the sensor, as opposed to the field of view, which is in object space. It's the angle that the lens is looking out onto the world. So those two things obviously are linked in a design, from a design point of view, but they're not codependent, so to speak. You can have very wide lenses with low CRA, and you can have narrow lenses with high CRA.
Good, thank you for that. We're getting to the full hour. Again, if there's questions that we haven't answered in the Q&A, we'll make sure we follow up by email. Here on this page, again, you have our contacts as well. And please just use this as a trigger for opening any discussions directly with Ben, with myself, or with Sunex, because we're here eventually to help you also find the right lens. And the tools are a good starting point, but we're more than happy to help you and start the dialogue and make sure your project can be successful with our products. So we want to conclude this webinar at this point. Again, if you go to sunex.com/webinars, you see the other webinars which are scheduled. We'll be happy to see you in one of the upcoming webinars, and also let your colleagues and peers know about this opportunity. Thanks for your attention. We're looking forward to talking to you soon.
Thanks, everybody.